or neither. So now we're going to determine if the following vectors are parallel, perpendicular, or neither. And actually, orthogonal. That's probably how I'll write it on the test. Determine if the following vectors are parallel, orthogonal, or neither. Losing my voice here. We've got negative 6, 3, and 2, negative 1. Okay, let's check the easy one. Let's check orthogonal. To do that, I'm going to find the dot product. Let's do v dot u. Multiply the first two I get. Negative 12. Multiply the second two I get. Negative 3. So v dot u is actually negative 15. So we know it's not orthogonal. Because if they were orthogonal, that would be 0. So that's what the dot product tells me there. Now I have to determine if they are multiples of each other. Sometimes that's hard to see. So what you could do to check is I always go the same direction. So that's true in every case. Why are you doing this? Board. It's messing with me. It's doing like this weird delay thing. Here we go. And it's still doing it. What the heck? Okay. So I say, gosh, I need to disconnect and connect again or something because it's not writing. Okay, let's try this again. Not cooperating. Okay. Sometimes it's obvious. Can you multiply one of these vectors by some number to get the other?
Yes.
Yes, what?
Can't. Multiply.
But what?
3.
3. Does everyone agree that if I multiply this vector by 3, I get this vector? Yes?
Yeah.
Okay, but here's how you could show it. You could say negative 6 times what? And I'll even make that darker. Equals 2. Right? I'm taking this and I'm saying, can I times a number to get this? That's what I'm saying. That number would have to be negative a third, right? So I'm saying 6 times negative a third is 2. Now check it. If I take 3 and I times negative a third, do I get negative 1? Yeah. So you can set up an equation because they're not all going to be this obvious. Okay? But we can see that they're multiples of each other. And I need an explanation so I can follow your logic. Just do 2 times negative 1. If I times that by 3, I get negative 6, 3. Or you could say negative a third times negative 6, 3 is 2, negative 1. Either one of those is the same explanation. So, therefore, they are parallel.
Would the top one be negative 3 too?
Yeah. But you see how I gave an explanation? I said this vector times this number gives me the other? On a quiz, and this, I want everyone to listen to this very carefully because I will be strict about this. And I say it on the quiz and people ignore it. If I give you this problem, writing parallel, perpendicular, or orthogonal is not enough. Not even close to enough. You have to have work to back it up. Work or an explanation. In this case, I had an explanation to show my parallel. Okay?